All right, welcome to the video for page 2 of lesson 1.3, fractions, decimals, and percents. And so what I'd like to do is just explore each of these and how they represent parts of a whole. So remember, we're talking about parts of a cookie. We're no longer talking about whole cookies. And so with a fraction deals with this by specifically looking at a top number. We're going to call this a numerator. A numerator, and then a denominator. Sorry about that. Denominator. There we go. Numerator and denominator. Now, we can just call it top number, bottom number, but those are the official names for it. And so, what do these numbers represent? So the bottom, the denominator, this is really important. This is the number of pieces that make a whole. W-H-O-L-E, right? So in other words, the whole or total. So in other words, if I break apart a piece of, if I break apart a cookie, how many of those pieces will it take to get a whole cookie back? So that's really what this is. How many pieces does it take to make a whole cookie? Or how many pieces was the cookie broken into? Now the top number is how many pieces you have. So fractions are really used to represent when you don't have all the pieces. But you want to get an idea of, well, how much of that cookie do I have? Do I have almost all of it? Do I have very little of it? Like, how do I measure that? How do I assign values to that? So let's take, we'll start with the fraction 1/4. So it takes 4 pieces to make a whole cookie. And we have one of those pieces. So let's draw a cookie. Hey, that's a pretty good freehand circle. And then I'm going to cut this cookie into 4 pieces because that's what this says, right? It says it takes 4 pieces to make a whole cookie. And so I've represented that cookie cut into 4 pieces. Now the top tells me this is how many pieces I have. So I'm actually going to shade this piece. This represents the actual piece that I have. These are gone. These are empty. These don't exist. But it would take 4 of these to make a whole cookie. I only have 1 of them. Now, 1/4, it's pretty easy to represent it with the drawing. Because I only have to draw 4 places, or I only have to separate it into 4 sections and show that I have 1 of those sections. What if I had 1/100th of a cookie? Like, how would I draw that out to show that what that meant? I mean, I would have to take a circle and somehow cut it into 100 even-sized pieces and then shade one of them. I think it'd be really, really difficult to do. So here, I'm drawing not provided. Right? So it's a lot easier to conceptualize when you have nice, simple, easy, small numbers for it. Then you can draw like a pie and get a real good view of it. This 1/4 is pretty easy to use mathematically. And so when our fractions are real simple like that, that's probably the way to go, is to go with that fraction. Consider this fraction. Consider 21/29. Well, this would be harder to draw. It's harder to kind of conceive of visually. So it's not a nice, easy fraction to do, but the idea is still the same. 29 pieces, and they're all equal sized, would make a full cookie, and you only have 21 of those pieces. But this is not a great way to get a feel for the size because the numbers are so awkward. When I say 1/4, I get a very clear picture of what 1/4 looks like. But 21/29, not so much. So when do we use fractions? Well, I think we like to use fractions when they're easier, right? If they're like 1/4, that makes sense. When they're harder fractions, we're more likely to try and represent this in a different way. All right, so that is how we are representing fractions. Let's talk about decimals. Now, decimals, and let's give an example of a decimal. So 0.4. This could also be written as just a 0.4. And we talked a little bit about this in class. The reason we put the 0 in front is because if somebody put a 4 and then put a dot here, but they weren't real careful about it. So if they put a 4 and there's like, I put a dot, you can barely see it. Like there's a dot there now. Well, somebody might go, was that dot intentional? Is it supposed to be there? Is this a 4 or a 0.4? I don't know what this is. But if I put a 0 in front of it, then you feel pretty confident that dot was intentional because you'd never just put a 0 in front of a 4. So writing the 0.4 is probably a good practice. It's not required, but it's a good practice because it takes away any uncertainty. So what does this represent when I say 0.4? Well, this is actually 4 out of 10. So I'm going to draw a box. Cut that box in half. And then I'm going to cut this into 5 equal parts. So what I've done is I've made 10 boxes. And I'm going to shade 4 of them. So when we say 4.4, we're really saying 4 out of 10. Because this is one decimal place. This is called the tenths place. So you can rewrite a decimal as a fraction. If it's just one decimal place, it's whatever that number out of 10. So if it's one number, it's always out of 10. If you go to a calculator and you divide 4 by 10 on your calculator, it will give you that 0.4. And let me grab my calculator real quick. Calculator, but my wife had one I could borrow, so she's a sweetheart. All right, so for this one here, 4 out of 10, if I take 4 and I divide it by 10, I do get 0.4. So 4/10 and 0.4 they represent the same amount. And so whenever you have one decimal point, it's always going to be that number over 10. If this is 0.3, it'd be 3/10. If it was 0.7, it'd be 7/10. So decimals are always out of 10 if it's one decimal. But what if it's two decimals? So what if I had 0.35? Okay, well, now it's 2 decimal places. This is out of 100. So this would be 35 out of 100. What's the visual for that? Well, I'm going to have to draw a big box here, and I'm going to have to cut them into 10 columns and 10 rows. So if I cut this in half, and then I'll draw 4 lines here, and that gives me 5 columns. I'm going to do the same thing here. I'm going to draw 4 lines. That'll make 5 columns. So if you count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to do the same this way. So try to draw a line right in the middle. Then I'm going to draw 4 lines across in this top half. 1, 2, 3, 4. Hey, that's pretty even. 1, 2, 3, 4. Not bad for a guy who can't art. So there are 100 boxes there now. This is 0.35. So I need to shade 35 of these boxes. Well, I'm going to shade 3 rows, because that's 30 boxes. If they're rows of 10, I don't think I'm doing a great job with this shading. I'm a fan of mechanical pencils, but they are not great for shading. A regular pencil is actually better. All right. Sorry you had to sit here and watch me shade. You know, you can fast forward through the shading. And then I'm going to shade 5 more boxes. Here we go. That's 35 boxes. So 35 hundredths, or 0.35, that's what it represents. That you would have 35 out of 100 boxes. So you have an idea. It's certainly less than half, right? But now we have kind of a visual for how much that's worth. So if it's one number after the decimal, it's out of 10. If it's 2 numbers after the decimal, it's out of 100. What if it was 3 numbers? And we'll just do one more example. And so let's say I say 125. Well, that would be 125 out of, what do you think? If you guessed 1,000, you got it. So if it's 3 decimals, it's out of 1,000, and it just continues. 4, add a 0. If it's 5 decimals, add 2 more zeros, right? That's kind of the pattern for it. But that's how the decimals represent parts, is they are either in tens, out of 10, out of 100, out of 1,000. And this works really well, as we talked about, for money. In monies, we do this all the time, 35 cents. So this gives you kind of a visual of how much 35 cents is out of $1, right? It's this much of the entire area. So you get a nice visual, so you can have a sense how much that is. So it's certainly not close to all of it, right? It's definitely less than half. All right, let's take a look at the last one. This is going to be percents. And so I want to break down this word, and from now on, I would like you to think that whenever you hear percent, I want you to think right afterwards, per hundred. Because cent means 100. If we think about pennies, we call them cents because there's 100 pennies in $1. In a century, there's 100 years. In the Roman Empire, you had centurions, and they were in charge of 100 men. And so this cent means 100. So when you see percent, immediately think per 100. And so the percent actually fits this model really well. It's how many out of 100. I don't want to redraw the box, if you guys are okay with that. I don't want to redraw it. If you want to redraw it on yours, you can. But if I said 30%, that would be 30 per 100. Right? Or 30 out of 100 if you put it as a fraction. And if I were to use this model for it, I would have 3 shaded rows instead of 3.5 shaded rows, right? So it would just be those 3 rows out of 100. That's all a percent is. It's out of 100. And this works really well because out of 100 tends to make more sense, I think, for people in general. So if we go back to like this 21 out of 29, this is not really easy to conceive of, but things like out of tens and out of hundreds are easier for us to wrap our brains around. And so this is why I think we came up with these systems, because the fractions can be really awkward when the numbers are weird. And so we get better values from this. All right, so that's just kind of a rough idea of how we represent each one, how they represent parts of a whole. But what we're going to do now in the next lesson is we're going to start talking about how do we show the same value, the same amount in all 3 forms. So I'm going to stop this video here, and please continue on to part 3 or page 3 of this video.